What I want to do now is show you that there's often more than one way to get to the same answer. So this is the same question we've just looked at. And we set up knowns, we set up unknowns. I'm going to keep those things. We drew a picture. I'll keep that. The next thing we did was to calculate acceleration. Okay, so we calculated acceleration, found it to be 5 meters per second squared. But I've erased what we used to have here. What we did here was we calculated what the final velocity was at t equals 60 seconds. So now we haven't done that yet. You can take this acceleration straight here to what we did before. We calculated this through and found equations for delta x. I went ahead now and calculated the delta x at 60 seconds. I came up with 9,000 meters. So if we had done this first without calculating v, then this equation would have been useful. See, we've got final velocity squared equals initial velocity squared plus 2 times acceleration times the displacement. So initial v, this is our v naught, so that's 0. So that's equal to 2. Acceleration, 5 meters per second squared. Delta x, I now have is 9,000 meters. So that v final at 60 seconds equals, this was squared, so I have to square root 2 times 5 meters per second squared times 9,000 meters. And this, if you calculate that, will give you the same answer that we had here before. So there's often more than one way to do it. Sometimes one way is much easier than other ways. Sometimes there are just a lot of different possible ways you can go.